Welcome to section 4.1, first derivatives and graphs. Our goal today is to use our first derivative to analyze the graphs. Our first theorem is about increasing and decreasing functions. So if we're looking at an interval from a to b and our derivative is positive, that means our function is increasing and the graph of f rises. If our derivative is negative, then f of x is decreasing and the graph of f falls. There are critical values in which it is the derivative of f is 0, or where our derivative does not exist. These are areas in between the increasing and decreasing parts. So, the first derivative test for local extrema is let C be a critical value, so we're focused on our critical values, and we'll construct a sign chart for our derivative close to on either side of this critical value C. Then f of C will be a local minimum if the derivative changes from negative to positive, a local maximum if the derivative goes from positive to negative, or neither a max or a min if f prime does not change signs. And we'll see what that looks like not only algebraically but graphically as well. So, given the function f of x equals 3x cubed minus 81x plus 13, let's find f prime of x, the critical values, and the partition numbers for the first derivative. So, f prime of x, let's take the derivative. 3x cubed becomes 9x squared minus 81x minus 81. 13, derivative is 0. Okay, next we have the critical values of the function, and remember that's where our derivative is 0. So where f prime is 0, f prime being 9x squared minus 81. So where is this squared? Well, let's move the 81. Let's divide the 9. And square root. So it looks like our critical values are 3 and negative 3. So the partition numbers for our first derivative would be at 3 and at negative 3. That's where we would partition it out, and if we were going to follow our first derivative test, we would look around negative 3 and positive 3 and see what's happening. Given the function f of x equals 21 over x plus 3, find f prime of x, the critical values of the function, and the partition numbers for the first derivative. So let's first do f prime. Let's see how much space. We have plenty of room. So what we'll do is let's rewrite this actually before we jump into our derivative. So if I rewrite this using my exponent properties, I'll have x plus 3 to a negative 1 power. And that will let us do the power rule. So we have negative 21 x plus 3 to the negative 2, and then the chain rule would be times 1. So this is negative 21 over x plus 3 squared. Okay. the critical values are where f prime of x equals 0, and in order for our fraction to equal 0, the numerator has to equal 0. And in this case, our fraction is always a negative number and never equal to 0. But we do have a spot where our function would be undefined. So that's what we're going to look at next. So this tells us it's never equal to 0. But we know that is undefined when the denominator equals 0. Okay. And this will happen, so if we square both sides, then it will happen at x equals -3. Now, the thing about -3 is it's not in the domain of f. If we go back to our function and we plugged in -3, it's not in the domain. So we are not going to be using this as a critical value either. Not in the domain of f of x. So we end up not having any critical values. So part C, the partition numbers of the first derivative. Well, our partition numbers are found by setting the derivative equal to 0, which can't happen here, and where it's undefined. So the only way we're going to have a partition number is going to be at -3. We'll look around -3 because that's where it was undefined. In problems 3 through 5, for the functions given, find the intervals on which the function is increasing, the intervals on which the function is decreasing, and the local extrema. So now we're going to take it a step further and not just find our critical values or our intervals, our partition numbers, that's what the word. But we're going to use the partition numbers and see what's happening around them so we can determine where is it increasing and where is it decreasing. So our first one, f of x equals 5x squared plus 20x minus 12. First, we want to find the derivative. 5x squared, 10x. 20x, 20. 12, 0. So now we have our derivative, and we will set the derivative equal to 0 to find our critical values. If we divide by 10, we get a -2. And now we will look around -2 to see what's happening on either side. So if I go on the negative side of -2, we'll check what happens at -3. If we go on the positive side of -2, I'm going to use 0 because I like using 0. It makes it a lot easier to look at and calculate. And we'll see what's happening around this critical value. So if we plug in -3, we'll have 10 times -3 plus 20, which will give us -30 plus 20, which will give us -10. So over here we have a negative. And then if we plug in 0, we have 10 times 0 plus 20. So we have 20, which is positive. So to find out the intervals on which the function is increasing and the intervals on which it's decreasing, we're just going to look at where is the derivative positive and where is it negative. So the function is increasing from -2 to positive infinity. That's what it's telling us on the positive side. We're not including -2 because that was the critical value. The function is decreasing from -infinity to -2. And we are decreasing, so the function is going downwards, and then we are increasing, so the function is going upwards. So at -2, we would expect it to be a minimum value. The bottom of the bowl is how I describe it. So the critical value -2 is a minimum. And we can even find the point that the minimum is at by just plugging in the -2 back in. So if we take f of -2, 5 -2 squared plus 20 times -2 minus 12, 5 times 4 minus 40 minus 12. So we'll have -32 at -2, -32. Okay, let's do another. F of x equals 3x cubed minus 81x plus 13. So let's start with our derivative. F prime is 9x squared minus 81. Then we want to find our critical value, so we will set our derivative equal to 0. So 9x squared equals 81, x squared equals 9, x equals positive and -3, familiar from before. And so we will look around -3 and +3. So on the negative side of -3, we'll try a -4. In between -3 and +3, we'll try a 0. And on the positive side of 3, we'll try a 4. So f prime of -4 will give us 9 times -4 squared minus 81. 9 times 16 minus 81. 144 minus 81. 63. So this is positive. F prime of 0. 9 times 0 squared minus 81, so -81. negative. And f prime of positive 4, 9 times 4 squared minus 81. That's going to give us the same 63, a positive. So, the interval where it's increasing, the function is increasing looks like from negative infinity to negative 3 and from 3 to positive infinity. Then the function is decreasing from negative 3 to positive 3. That's where our negative zone is. And so, since it's increasing, that means our function's going up. And then it's decreasing, which means it's going down. So here it looks like we would have a max. And then it's decreasing, and then it's increasing. So here it looks like we would have a min. So we would have a maximum at negative 3 and a minimum at positive 3. The critical value x equals negative 3 is a maximum, and we can find out f of negative 3 times negative 3 cubed minus 81 times negative 3 plus 13. 3 times negative 27 plus 3 plus 13. Negative 3 is going to be 175. And the critical value 3 is a minimum. So we'll find f of 3 this time. 3 times 3 cubed minus 81 times 3 plus 13. Times 27 minus 243. Now we've got negative 149. Okay, let's look at another. F of x equals 3x to the 4th plus 4x cubed minus 8. Let's find our derivative. 3x to the 4th, 12x cubed, 4x cubed, 12x squared. Derivative of 8 is 0. Now we'll set this equal to 0 to find our critical points. And so, let's see, we can factor so in this one x equals 0, in this one x equals negative 1. Okay, so now we can look around negative 1 and 0. So on the negative side of -1, we'll look at -2. In between -1 and 0, we'll look at 0.5, negative 0.5. And on the other side of 0, we can look at, since we're looking at -2, we can look at +2, I suppose. Okay, so f prime of -2 is 12 times -2 cubed plus 12 times -2 squared. Oh, that's so messy. Okay. So 2 times 2 times 2, 8, -8 minus, no, plus 48. So we've got negative 48. So a negative on this side. Negative 0.5. I'm going to put 1/2 to see if we can fit it. Okay. So we have 12 times -1/8 plus 12 times 1/4. So we've got -3/2 plus 3 is +3/2. And then f prime of 12 times 2 cubed plus 12 times 2 squared. 8, 4, 144, positive. So the function is increasing. And you may be tempted to say from -1 to infinity, but remember it's not increasing at the critical points. So what we're going to do is we're going to say it's increasing from -1 to 0 and from 0 to positive infinity. The function is decreasing from -infinity to -1. Now, this one, it's decreasing, so it's going down. And then it's increasing, so it's going up. So we would expect this to be a minimum. And then it keeps going up. So 0 is not, it's not doing anything. So it's not a max or a min. Remember, we can have that happen sometimes. So the critical value, -1, is a local minimum, and we can find out f of -1, let's see. 3 times -1 to the 4th plus 4 times -1 to the 3rd minus 8. So we'd have 3 minus 4 minus 8, -9. And x equals 0 is not a local extrema. Okay. In problem 6 and 7, for the functions given, find the intervals on which the function is increasing, decreasing, and then sketch the graph. Okay. So we'll do our same process. Let's find the derivative. F of x equals 2x cubed. I think this is a typo. We don't need that. 2x cubed plus 3x squared minus 12x. So, derivative. 2x cubed is 6x squared. 3x squared is 6x. 12x is 12. Now we set our derivative equal to 0 to find our critical values. So first let's factor out a 6. And then we will factor x and x, 2 and 1, positive, negative. Okay. So x plus 2 equals 0, x equals -2, and x equals 1. So we will look around -2 and +1. So let's look at -3, let's look at 0, and let's look at 2. F prime of -3. We'll have we'll have 6 times -3 squared plus 6 times -3 minus 12. 6 times 9 plus, we got 54 minus 18 minus 12, which will give us 24. So we have positive 0 will give us 6 times 0 squared plus 6 times 0 minus 12, so we'll have -12. And 2 will give us 6 times 2 squared plus 6 times 2 minus 12. 4. So this will give us positive 24. Okay. This is telling us the function is increasing from -infinity to -2 and from 1 to positive infinity. it's decreasing from -2 to +1. And we want to sketch it, so let's see. We are going here's -2 and here's 1. So it's telling us that it is going from increasing to decreasing to increasing. So we are going to go, I think I want to find out what my points are. So I'm going to find out what f of -2 is, so that way we know the point that is our maximum, because we're going to have a max and then a min. So let's find out where these are. F of -2 is going to give us 2 times -2 cubed plus 3 times -2 squared minus 12 times -2, 2 times -8, 3 times 4, 24, -16 plus 12, 24, 4. Okay, so our point is going to be -2, 8, and then 1, -2 plus 3 minus 12, 6 minus 12, -6. So at 1, it's down to -6. So our graph is going to go something like increasing, hit the max, decreasing, hit the min, increasing. Something like that is what we would expect if we graphed our function. Okay, let's try another example. F of x equals x cubed minus 12x plus 4. Let's find that derivative. 3x squared minus 12. Let's find our critical values. Three x squared equals 12, x squared equals 4, x equals positive and -2. So we'll look at -3, 0, and +3, just to keep it symmetric, I suppose. F prime of -3 will give us 3 times -3 squared minus 12. 3 times 9 minus 12. 15. positive. Zero, 3 times 0 squared minus 12, so negative 12. And positive 3, 3 times 3 squared minus 12. That's going to give us the same, 15. So we have increasing to decreasing to increasing, max, min. Let's find the values of these before we graph them. So f of negative 2 will give us negative 2 cubed minus 12 times negative 2 plus 4. So we have negative 8 plus 24 plus 4 is going to give us negative 8 plus 28, 20. And then we've got f of 2, 2 cubed minus 12 times 2 plus 4, 8 minus 24 plus 4, 8 minus 20, negative 12. Okay, so we have some points now. We said at negative 2, it's at 20. And at positive 2, it's at negative 12. So it's going to go from increasing to decreasing to increasing, something like that. And if we graph f of x, that's what we would expect to see.